Now the next chapter is product of vectors. What is this product of vectors? It is not like ordinary multiplication. Multiplication of vectors is not like ordinary multiplication of numbers. Like see, in real numbers, suppose I have to multiply 2 into 3. I'll write 2 into 3 and then 6 like this. And then I can also write 2 dot 3 is equal to 6. We use these notations in multiplication of real numbers into, or we sometimes will write a dot like that. But whereas in vectors, if A and B are vectors, A and B are two vectors, non-zero vectors. If I write a dot, there is one definition. If I write a cross between them, there is another definition. It is not like ordinary multiplication of real numbers. Here the definition is totally different. We write A dot, we define A dot B as mod A mod B into cos of angle between A and B. And then A cross B is defined as mod A into mod B into sine of angle between A and B into n cap, where n cap is a unit vector perpendicular to the plane containing A and B. N cap direction is like this. A and B are in this plane. A vector and B vector are in this plane. This is the direction of n cap where the rotation is in the right-handed system. So all that we'll learn in. So here A dot B is mod A, length of A into length of B into angle between, cos of angle between A and B. So all these are numbers. So the product is a number. So this is called as a scalar product. It is called as the scalar product of two vectors. Scalar product of two vectors. And between them we use the symbol dot. So dot denote, because of that we call this as dot product. Now cross product, when you write cross between A and B, it is defined as cross product, and it is mod A, it is a number, and B mod B is also a number, sine of angle between A and B is also a number, and n cap is a unit vector perpendicular to the plane containing A and B. So all this is a number. Some number into a vector is a vector. So this is a vector. Because of this, it is also called as the vector product. So dot product and cross product are two different types of, two different kinds of products that we define in product of vectors. Now first we'll study about this scalar product. In this chapter, you will study about the scalar product of two vectors, scalar product or dot product, scalar product or dot product of two vectors, dot product of two vectors A and B, two vectors A and B. And then next you will learn about vector product of two vectors. Second topic, like in this second topic is vector product of two vectors, and then we'll define triple products between three vectors. We call them as triple products. In this again you have scalar triple product. This again you have scalar triple product and vector triple product. Scalar triple product and then vector triple product. Two kinds are there. And then again vector triple products, and then you have product between four vectors. How is the product between four vectors defined? Product between four vectors. So all this you will learn in this chapter. First you will learn about dot product, then again vector product or cross product, then triple product, then the products between four vectors. So these are the four things that you learn in this chapter. Now first we'll start with scalar product or dot product of two vectors A and B. The scalar product of two vectors, as I explained here, A dot B is mod A into mod B into cos of angle between A and B. So suppose that the vectors are A and B are like this. This is A and this is B. Now the angle between A and B is AB. We denote like this theta, or we use this symbol. You have already learned about this symbol in addition of vectors. Now A dot, what is B dot A? B dot A is equal to mod B into mod A into cos of angle B between B and A. Angle between A and B is same as angle between B and A. So this is same as A dot B. So this is one property. It is commutative. Dot product is commutative. A dot B is equal to B dot A. Now the next property is A dot of B plus C is equal to A dot B plus A dot C. It is commutative and it is also distributive with respect to addition. So A dot B plus A dot C. These properties are very important. And then A dot of B dot C, like that, is not defined. This is not defined. Okay. Next, suppose what is B is also equal to A. Then it becomes A dot A. A dot A is equal to mod A into cos of angle between A and A. When A coincides with A, what is the angle between A and A? This is A and it is again A. So the angle between A and A is 0. So cos 0 is 1. So it is mod A square. So A dot A is equal to mod A square. This property is very, very important, and most of the problems, wherever we come across this mod A, we'll write mod A square. We'll square on both sides. We write mod A square as A dot A, and then we use this definition. So these are some of the properties. Some more are there. First I'll explain and then give you the summary. So this is about the commutative property, distributive property, and then mod A square. And then so you have A dot B as mod A into mod B into cos of angle between A and B. No? So the angle between A and B, you bring this to this side. So A dot B by mod A into mod B is cos of angle between A and B. Cos of angle between A and B. So angle between A and B is given by the formula cos inverse of A dot B by mod A into mod B. So the angle between two vectors is given by this formula. There are many problems where we find the angle between two vectors A and B. Like suppose you have to find the angle between 2A plus B and then 3A minus B. Then the angle between them is given by the formula. This is just an example. So this is your vector A and this is your vector B, like that, and apply this formula. So this dot should be visible. Wherever you are writing, this dot should be visible. So then it represents dot product. So 2A plus B dot of 3A minus B, 3A minus B by mod of 2A plus B into mod of 3A minus B. So like this, according to the problem, we'll write the formula and then we'll find the angle between the vectors. So A dot A and then A dot B is equal to B dot A. Next is, suppose I have like this, 2A dot 3B or 2A dot minus 3B. Then you can just multiply these numbers. 2 into minus 3, ordinary multiplication. 2 into minus 3 is minus 6. And then take the dot product between A and B. 2A dot minus 3B is minus 6 into A dot B. A dot B, again you have the formula, you'll apply that. Next we have these identities. A plus B whole square is same as mod A plus B whole square. When you are squaring, you can write in this form, and as you know, mod A square is this, no? So mod A plus B whole square is A plus B dot A plus B. A plus B dot A plus B, which is equal to, expand this, A square plus B square plus 2A dot, or else you can use this property. What is it? Distributive property. This distributive property, when you use it, is like this. When you use the distributive property, it is A dot of A plus B plus B dot of A plus B. So you can also expand like this. So it is A dot A plus A dot B plus B dot A plus B dot B. A dot A is nothing but mod A square. A dot B is same as B dot A. So this becomes 2 times A dot B. And then B dot B is mod B square. So like this we'll expand. And then in the same way you have A minus B whole square as A square minus 2A dot B plus b square. You already have these formulae identities, but instead of ab, 2ab, you should write a dot b. A square means mod a square, b square means mod b square, like that. The same way, a plus b dot a minus b is equal to a square minus b square, or it is mod a square minus mod b square. So we have the formula like this. Have you understood? We'll summarize all this. First try to understand. So a plus b whole square is a plus b dot a plus b. So it is a square plus 2a dot b plus b square, like that. So a dot a means mod a square. Cos of angle between the vectors is a dot b by mod a mod b. So angle between the vectors a and b is cos inverse of a dot b by mod a mod b. Now we have these unit vectors I and j. So what is I dot a? According to the definition, it is mod I into cos of angle between I and I. Angle between I, or else it is mod I square. Both are same, no? So a square is a dot a, so it is mod I square. So what is mod I square? Modulus of I is 1, so it is 1. So I dot I is 1, j dot j is 1, k dot k is also 1. Next, I dot j. According to the definition, it is mod I into mod j into cos of angle between I and j. What is angle between I and j? I is along x-axis, j is along y-axis. I is along x-axis, j is along y-axis. The angle between them is 90 degrees. So cos of 90 degrees, cos 90 is 0. So I dot j is 0. Similarly, j dot k is 0, k dot I is 0. I dot I is 1, j dot j is 1, k dot k is also equal to 1. Now we'll write one important formula which we use in many of the problems. That is, suppose you have A as a1i plus a2j plus a3k and B as b1i plus b2j plus b3k, and you are finding the dot product a dot b. A dot b is a1. Proof is not necessary. It is, if you just learn the formula, that is enough, and understand how we are getting this formula, b1i plus b2j plus b3k. Okay, according to the distributive property, you can take term by term. So a1 b1. So you can multiply a1 b1 into I dot I, that is 1. Next, a1 b2 into I dot j is 0. Similarly, a1 I dot b3k means a1 b3 into I dot k is again 0. So only this term will remain. Or else, if you want, you can write all that, it will take time. I dot I, and then next is a1 b2 into I dot j plus a1 b3 into I dot k. In the same way, you take now a2. So a2 b1 into j dot I plus a2 b2 into j dot j plus, like this you write all the terms. Then I dot I is 1, j dot j is 1, next k dot k is 1. All the remaining terms are 0. So after simplification, you will get a1 b1 plus a2 b2, a1 b1 plus a2 b2 plus a3 b3. This is the formula. So when you are given a vector and b vector in terms of ijk, in terms of ijk only, not in terms of any other vector. If it is given in terms of a, b, c and all, you cannot apply this formula. Only in terms of ijk, you can apply this formula. If a and b are in terms of ijk, you can apply this formula. So just multiply I coefficients plus multiply j coefficients plus multiply k coefficients and write the value. That gives you a dot b. Now suppose that a dot b is 0. A dot b is 0 means mod a mod b cos of angle between a and b is 0. So this means that either a is 0 or b is 0. A is a 0 vector or b is a 0 vector, or cos of angle AB is equal to 0. That means angle between A and B is 90 degrees. So in most of the problems, we will be given two non-zero vectors to show that they are perpendicular. To show that A and B are perpendicular, you can show that their dot product is 0. If A and B are not 0 and A dot B is 0, then A has to be perpendicular to B. So if A dot B is equal to 0, then A is perpendicular to B, then A and B are non-zero vectors. So these are some of the important properties of dot product. Now we'll summarize all these properties and then we'll write the notes. After that we'll do few problems. Okay. First, we'll write the summary of all the points that we discussed. So the scalar product or dot product of two vectors written as A dot B is defined as mod A into mod B into cos of angle between AB, where AB is the angle between the vectors. And then A dot B is a scalar. The value of that is a scalar. And then A dot A is mod A square, because angle between A and A is 0. So cos 0 is 1. So A dot A is mod A square. And then A dot B is B dot A. A dot B plus C is A dot B plus A dot C. Then LA plus MB. L and M are some real numbers. Then it is like this. You can just multiply the real numbers and take the dot product between the two vectors only. Then this is these are the identities in dot product. A minus B whole square means A square minus 2A dot B plus B square. Same like how we have in algebra. These are the identities, but you must put dot here. A plus B plus C whole square means A plus B plus C dot A plus B plus C. So when you expand, you know the formula A square plus B square plus 2AB plus 2BC like that. So here I should write 2A dot B, B dot C like that. And then next property is I dot I is J dot J, K dot K is 1. I dot J so on is 0. Then if A and B are given in terms of I, J, K, then you can write A dot B as A1, B1. Just multiply the coefficients of I plus coefficient, product of coefficients of J plus product of coefficients of K. Simplify. Then this is the next property. Angle between two vectors A and B is given by cos inverse of A dot B by mod A mod B. And then if A and B are non-zero vectors and A dot B is 0, then implies that A is perpendicular to B. A is perpendicular to B. So these are the properties. Just copy down all these properties and then we'll solve the problems. Just to copy down all these properties. These are all, if you could have all these points in your mind, then easily solve the problems. Now, just copy, we'll try few problems. We'll solve the problem. Now, first problem, find the angle between the vectors. These are the two vectors. So, we take the vectors as A and B. A is equal to I plus 2J plus 3K. Let A is equal to, next B is equal to the second vector. We have the formula for angle between the vectors as cos inverse of A dot B by. So first we'll find A dot B. A dot B means A1 B1. So 1 into 3 plus A2 B2. So 2 into minus 1 plus A3 B3. So 3 into 2. So when you simplify it is 3 minus 2 plus 6. That is 7. Now find mod A. Mod A is root of 1 square plus 2 square plus 3 square. 14. Okay, next we'll find mod B. Mod B is equal to root of this 3 square plus minus 1 whole square plus 2 square. This is also root 14. So the angle between the vectors A and B is, therefore, angle between the vectors A and B. Angle between the vectors A and B is given by the formula cos inverse of, first write the formula. For writing the formula, I'll get 1 mark. Mod A into mod B. So this is cos inverse of A dot B. A dot B is 7. 7 by root 14 into root 14. That is 7 by 14. That is half. Cos inverse of half is cos 60. Cos 60. So 60 degrees. The angle between the two vectors A and B is equal to 60 degrees. So this is your answer. So like this we find the angle. This type of problems are very important for 2 marks. Now A and B are given. You must find the angle between the vectors 2A plus B and A plus 2B. So first we'll find 2A plus B vector. In the solution, we'll find 2A plus B. What is 2A? 4I plus 4J minus 6 plus B vector. Add B vector 3I minus J plus 2K. Now the procedure is same. Just find 2A plus B. So that is 4 7I plus 3J minus 4. Next find A plus 2B vector. J plus 2B is 2I plus 2J minus 3K plus 2B. Multiply this by 2. So 6I minus 2J plus 4. So when you simplify it is 8I. 2J gets cancelled. So it is plus K. Now find modulus of 2A plus B. That is root of 7 square, that means 49. Or and that 7 square plus 3 square plus minus 4 whole square. So that is 49 plus 9. 60. Root 74. Now find the modulus of A plus 2B also. So that is root of 8 square plus 1 square. Now find 2A plus B dot A plus 2B. So in the formula we need this. So take the dot product. 7 into 8 plus 3 into 1. So 3 into 0. J is not there. So minus 4 into 1. So the angle between the vectors 2A and 2A, angle between the vectors 2A plus B and A plus 2B is given by cos inverse of 2A plus B dot A plus 2B by mod of 2A plus B into mod of A plus 2B. The formula is same, but instead of A and B, you have 2A plus B and A plus 2B. Now simplify. Cos inverse of, you have all the values. So when you simplify, it is 52 by root 74 to root 65. So this is your answer. Then these are the two vectors which are perpendicular to each other. You must find lambda. So we know these are non-zero vectors. So when they are perpendicular, the vectors, these are the vectors. The vectors A is equal to lambda I minus 3j plus 5k and B is equal to 2 lambda I minus lambda j minus k are perpendicular to each other. So we have the property as A dot B is equal to 0. Now what is A dot B? A1 B1. So lambda into 2 lambda plus A2 B2. That means minus 3 into minus lambda plus A3 B3. So 5 into minus 1 is equal to 0. Just solve this equation and find the values of lambda. So you are getting 2 lambda square plus 3 lambda minus 5 is equal to 0. So you can find factors, or you can also use the formula lambda is equal to minus b plus r minus root of b square minus 4ac by 2a. So you can use either this formula, or you can use factors minus 10 by 4 or 4 by 4. That means minus 5 by 2 or 1. So this implies lambda is equal. So you can use this formula, or you can also find factors. So what are the factors? 2 lambda minus 5 into lambda minus 1. You will get like this. You can see 2 lambda square plus this is equal to 0. So you will get lambda is equal to minus 5 by 2 or 1. You can do by any method. So like this we'll find the values of lambda. Now we'll take down the homework. Now take down this homework. We solved similar problems just now. So A and B are given. Find the angle between them. You know the formula. A dot angle between the vectors is cos inverse of A dot B by mod A mod B. So these are the two vectors which are perpendicular to each other. So you already know when the two vectors are perpendicular, A dot B is 0. So A dot B means A1 B1 plus A2 B2 plus A3 B3 is equal to 0. Solve for lambda. Even third problem is similar to that. We complete this